Okay, so again, I'll talk about what this absolutely convergent, conditionally convergent, and divergent means. Just for now, I just want us to kind of focus on working the ratio test. So the ratio test is useful. It's necessary when there's lots of exponents. It's useful when there's lots of exponents. I said that wrong. Useful for lots of exponents. Necessary when there's factorials. So I'm going to do two examples with factorials. So ratio test is necessary for factorials. Okay, so let's be careful how we're putting these together. So limit as n goes to infinity. So I'm going to have the n plus first term, right? So a sub n plus 1 will be 2 to the n plus 1 over 4n plus 1 factorial. Okay, so always the n plus first term on the top. So this is first. And I'm going to multiply by the reciprocal of the nth term, right? So this will be 4n factorial over 2 to the n. This is the nth term. This is the n plus first term. Okay, so let's talk about how we break apart factorials. So you know 4 factorial is 4 times 3 times 2 times 1. That's the same thing as saying 4 times 3 factorial. So 4 factorial is the same as saying 4 times 3 factorial. So if I have n plus 1 factorial, that's the same as saying n plus 1 times n factorial. Important to know. All right, so that I need to use right here. And as I'm writing this down, I'm going to break this one up. 2 to the n times 2 to the 1, so I don't make a mistake in canceling and lose a factor. So this here, so this n plus 1 factorial, I'm going to break it up as n plus 1 times n factorial. Okay, so let's see what canceling I've got. I've got the 2 to the n's going away, and I've got the n factorials going away. So what do I have left? So I'll have a 2 times a 4, so that'll give me an 8 in the numerator, right? And the denominator, just taking highest powers, I would get 4n. Letting n go to infinity, I get 0. Is 0 an okay number for ratio test? It is. This is my limit, right? This is my L. As long as that L is less than 1, and it is, then I get the conclusion, absolute convergence. All right, so let's look at the n plus first term on this one. So if I plug in n plus 1 everywhere there's an n, I get negative 1 to the n. 3, ooh, careful here. So I'd have n plus 1 plus 1. And in the denominator, I'd have 2, and then be careful. Look at where that n plus 1 has to go. So this negative 1 to the n, so I'd have 3 to the, n plus 2, correct? N plus 2, because you add those together. In the denominator, inside the factorial parentheses, I would have 2n plus 2. Be careful. Easy to make a mistake here. 2n plus 2. Okay, so now I'm ready to do my ratio test. So my n plus first term, again, because of the absolute values, right, that I'm not writing, I'm going to toss away the negative ones. So I have 3 to the n plus 2 over 2n plus 2 factorial, multiply by the reciprocal. So 2n factorial, 3 to the n plus 1. Okay. So I need to break this apart to be able to cancel with this. So let's keep going with this idea, right? Because you've got this idea memorized. So let's figure out, how does 2n plus 2 factorial break apart? So that would be 2n plus 2 times 2n plus 1 factorial. Let me make some room here. Okay, that's not quite where I need to go, right? Because I need to be able to cancel this with this. Can I do it again? I can. So this breaks up into 2n plus 1 times 2n factorial. Really big deal here. The 2n plus 2 breaks up into this. Okay, so let's break everything up so I can cancel. So I get 3 to the n times 3 squared, 2n plus 2, 2n plus 1, 2n factorial, 2n factorial, 3 to the n times 3 to the 1. So see how everything breaks up? This breaks up into these two. This breaks up into these two, right? And I broke this one up into these three. So now let's go through the canceling. So the 2n factorials cancel, the 3 to the n's cancel, and then one of the three factors goes away. So what am I left with? N going to infinity. I'd have one factor of 3 in the numerator, a 2n plus 2, a 2n plus 1. I'm letting n go to infinity. I get 0. That's less than 1, so this is absolutely convergent. All right. Ooh, let's see, lots of exponents, so this would be a good one for ratio test. So let's just dig in. So I'm putting in n plus 1. Everywhere there's an n. And then I'm multiplying by the nth term. Okay, so invest the time in breaking this guy up here, right? This one here. Do not multiply that out, right? That would be crazy. So I have negative 10 to the nth power times negative 10. Oh gosh, sorry, that's really messy. So negative 10, right? So I'm breaking up this n plus 1. So negative 10 to the n, negative 10 to the 1. Ooh, I forgot. This has the negatives on the inside, so I still need to keep my absolute value bars here, don't I? And so I've got this n plus 1 to the 10th plus 4. Okay, so I just broke things up so I can do some canceling. Okay, so these can cancel. All right, so what am I left with? Limit as n goes to infinity. Still in my absolute value bars because I never did take the absolute value because the negative 1 was kind of stuck inside. So here I'd get highest powers, right? This would be distributed times these two. So I'm just going to take the highest powered. So I get negative 10 n to the 10th. Highest powered from the denominator. Let's think about it. This here would be multiplied out, and the highest powered term would be 1 n to the 10th. So I cancel the n to the 10ths, and I take the absolute value of negative 10, and I get 10. So that's my limit. Since this is bigger than 1, I get that this diverges. So let me just make a comment about this one. I could have, in the beginning, separated this up. So I could have said this is, whoops, this is negative 1 to the n times 10 to the n. Correct? Because I could split this up. Because if I have a, b to the n, that's the same as saying a to the n, b to the n, correct? Then if I wanted to go do ratio test, by tossing out the negatives, right? So 10 to the n plus 1, n plus 1 to the 10th, m to the 10th plus 4, multiplying n to the 10th plus 4 over 10 to the n. So I wouldn't have to worry about, so this is the or, right? You could have done this, or I tossed off the negatives and took the absolute value, and so I still have to do the canceling of the 10s, right? The 10 to the n's, so I'd be left with a 10 up there, and I'd have this n plus 1 to the 10th, plus 4, all multiplied times 10 to the n. Then I could cancel the 10 to the, what happened here? What did I do? I went a little too fast here. Hold on. 10 to the n times 10. Okay, that's what I meant to write. I don't know what I did. Okay, so 10 to the n's would cancel, correct? because I'm just kind of breaking things up before I cancel. So 10 to the n plus 1 gave me 10 to the n times 10. Now, what do I have left? So I've got 10 times n to the 10th. And down here, by highest powers, I would have n to the 10th. So you can see I get 10. And so that still means diverge. So the work in the blue you could have done, or this black and red works as well.